So, hello, I'm an architect from Zenico projects Latvia, the company that mainly does residential and commercial buildings, and we focus on contemporary, efficient, and sustainable design. So first I'm gonna show you a couple of projects we've done before. This is an office building where we also focused on efficiency in terms of floor plan. It's very efficient layout, and it uses flexible space system, which is raised floor, so all the communications can be freely rearranged to make different floor plan layouts. Also, there is fully glazed double skin facade with solar shading in between, so it's very efficient also in ecological and climate aspect. And it's been finished in 2008, so it's already a couple of years actually more than a couple of years in use, and the owner is actually quite happy with the result and how the building performed. And it's a good example also for others. The other project that is right now going under reconstruction is an old factory building, and the main challenge here was also sustainability and insulation, because it has historic facade and we couldn't add insulation from outside, so we had to think something different. So what we came up was to leave this historic facade as external skin and build inside another fully insulated wall. So again, here it works as double skin. It also has sun shading between, and this facade can be ventilated. And because this internal wall is fully insulated, it meets all the standards inside. Also, it has raised floor because owner has very different needs for layout, and he's planning to change it very often. So to make it more flexible, it will be useful in future. But the building I'm going to tell about more is Microtik office building. It's actually average size office building, about 6,000 square meters of area. And yes, it's our latest project. And as it was told before, as efficiency and green building design is getting more and more popular, so we as architects also have to think about these things more and implement in our design. And the main things that we can do is actually to make the floor plan layout very functional, and not only functional for today but functional for tomorrow, that it can be rearranged later. And it's not only the floor plan, it's also all communications, that less energy and money is spent to use building for different needs in future. And of course using less energy to build it and less energy to use the building. So the Microtik building. The main design principle was to create a highly efficient building, a good indoor environment, a comfortable working place for users, and optimal lifelong performance. And as the owner builds this building for himself, not for selling or not for leasing or for renting, actually not for the main purpose. So he chose not to go for any certification like BREEAM or LEED. He just wanted to be more efficient and to spend more money in actually efficient things, not in certification. But that doesn't mean it doesn't meet the standards. So this is a typical floor plan layout, and as it wasn't already clear how the workplaces will be arranged, so we have typical open space office layout around the perimeter and all communications and services in the core. But also for later use or some other needs, this floor can be divided in as much as 8 separate offices, which then can be even more divided in some separate rooms. And as the owner wanted, the client actually wanted the building to be quite simple, but built fast, inexpensive, efficient, we saw that the precast construction could be the most efficient way to do it faster, easier, because the building is quite rectangular, simple shape. It's easy to done with precast construction, and of course it was at first the core, the slabs, the walls. Later we added actually a complete facade finish, and it's composite facade panel with complete finish. Also the windows will be already built in factory, so the panel is brought to the site already complete, put on the wall, and the wall is actually done. We wouldn't need any scaffolding around. And then we thought also about these climate systems, how to make them more efficient, more simple, and thinking how to implement that in different way that is more simple. We thought about those cores in floor slabs. We thought that they could be used not only for cables, but probably also for air. And as we did some research, we found that it has been done before, and it's actually nothing very new, but it is quite new in this region. So in this building we are using those floor slabs for climate system. And very good reason to do this is the thermal mass. As all the building is concrete, it's quite heavy. And why the thermal mass is good? Because it reduces the peak temperatures, which is very critical in use of the building. And also the resistance of these heavyweight materials gives the thermal lag. What it means is that, for example, in summer, the peak indoor temperature is shifting from working hours to later period when the building is already empty. And the same goes with cooling. You can cool the building during night and use this stored energy later in the day. For our building we used the thermodeck, a system that Consolis company presents. And what it is actually a fan-assisted heating, cooling, and ventilation system that uses those hollow core slabs. And the air passes through the slab, it cools down or heats up the slab, and the air later goes to the room. What is the main beneficial thing of this is that The slab itself works as a radiator, and the air that comes out is just about 1 or 2 degrees different from the room temperature. So you have very high room comfort. You don't have the air very cold or very hot, as it comes from chill beams, fan coils. This system gives much more comfort in these terms. So how does it work? This is a summer mode. In summer mode, when the days are hot but the nights are cooler, the system works how? During the night, when the air is cool, the cool air is pushed through those slabs, and the slabs are cooled down. If the night is not so cold, then of course you need to have some cooling, not with outside air, but also these chillers. And then, when the day starts, this slab is actually already cold and acts as radiator, and the outside air during the day is much hotter, but when it passes through this slab, which is already cooled down during the night, it actually comes out quite cool. And as the slab is quite heavy and quite big, it actually stores this cool air for almost full day, and also absorbs some of the heat that comes from computers and people. During the winter is a bit different, but also the building can be warmed up with much hotter air during night. The air is circulated inside the building. It doesn't take air from outside, so it's much efficient. Those slabs are heated up, and during day, when the outside air is pushed through those slabs, it needs to be warmed up much less, because the slabs already stores this temperature inside them. So how does it compare to conventional systems? For typical climate system in modern building, you actually need separate system for ventilation, separate usually radiators for heating, separate systems like fan coils or chill beams for cooling, and everything gets quite complicated. In terms of thermodeck, you actually just need this air handling unit in the building, and then all the other thing is done through ventilation and floor slabs. And it's much efficient than just cooling or heating with air, as in between there are those slabs which acts as thermal storage and works much more efficient than just air cooling. So here we have some main advantages and disadvantages. As I said before, there is significant reduction in all those fittings that is needed in the building. Building is much more simpler. As you don't need air ducts, but the air ducts are incorporated in 4 slabs, you can save much of the ceiling space. You save space on radiators. You have room planning for flexibility, because you don't have any duct working on the ceiling. The operation of the system is very quiet, because 4 floor slabs are very solid, and it very good absorbs the noise from ventilation machines. And because it works as radiating heat and cooling, it is more comfortable. Well, the main disadvantage is probably that you need some special assistance in designing, as this system is not very used to for typical engineers. So you need some assistance from thermodeck. Of course, there is some increased costs for the slabs, but then again it pays back because you don't need to put all other systems. And here is typical cost comparison. Of course, then natural ventilation is most cheap alternative. Then thermodeck is something in the middle, and of course air conditioning is the most expensive because it has more of those fittings. But even though the natural ventilation might be cheaper, it is far more or less flexible, and you can't have the climate so adjustable to meet the needs of modern office space. And as we can see, this in this long-term comparison, this thermodeck system actually gets more and more beneficial in long-term run, as it needs less maintenance, especially compared to air conditioning and heating system with separate and complex systems. This is one more alternative which was incorporated in those buildings I showed before. This is flexible space system that is also quite flexible, also in a way uses thermal mass, as it works it combines rise to floor, and in this underfloor space there is ventilation ducts which works also for heating and cooling, and as it is in direct contact with floor slab, it also cools down and heats floor slab. So the floor slab also works as this thermal storage. This system actually is more flexible than thermodeck because all those panels can be very freely arranged and adjusted to different office space needs. But of course, this system is much more expensive than thermodeck, which is actually quite primitive and easy system. So this is a cross section of our building. You see the office spaces around, the communication core in the middle, and there are these communication ducts where the air comes down from the air handling unit to the floors and is distributed to thermodeck slabs, and then the air goes through the slabs and comes out where you need. This is a typical floor layout, and as you see, there are very many outlets around the perimeter of the building. So actually all floor is covered with air, and as every slab is used for thermodeck, so this heating and cooling is very uniform. All floor gets very constant temperature. But when you need to rearrange to put some smaller offices, some smaller rooms, there is second duct for second array of outlets, which are marked blue, which are normally closed for this open space layout. But if you make some separate rooms inside, you can always open those outlets and have air also in those rooms. So it is very easily adjustable. You don't have to do any ductworking if you plan to divide the floor in many rooms or many different offices, it is actually very easy to adjust. So this is a closer view. You can see those ventilation outlets. They cover all the space. So in every room, every place, you have an outlet, even if you divide in quite small rooms. And as you see, the floor slab is actually quite low, and you have much higher ceiling height compared to system where there would be ventilation ducts and suspended ceiling, and the office is much more spacious in this case. So there are some numbers of air temperatures and basic thermodeck starting point temperatures, but everything is controlled by BMS, so that the temperatures could be adjusted as needed, and also this system could be also later modified depending on the needs, on the actual usage of the building, because it's now been designed for typical working day period, but probably in the real life this working day could be a bit different. So through the BMS, this algorithm of air temperatures can be adjusted. And what you can see here is actually that the highest heating temperature is about 30 degrees, but it's used actually on non-operating hours, and also for the cooling. The lowest temperatures are used for non-operating hours, so actually the room you are using during the day is cooled down or heated up during the night. So during the day, the temperature that enters the room is much more closer to the temperature that is actually the working environment. But actually, yes, the thermodeck is not everything. Of course, to be sustainable and efficient, you need to increase insulation, have better windows in terms of thermal and solar index. Of course, thermodeck also needs air, so there is air handling unit with heat recovery and free cooling mode, and everything is connected to BMS. And those numbers like U values and efficiencies are probably just a bit higher than the regulation, but we also chose to put those numbers in the project more optimistical, more real life numbers. But from constructor, we asked those numbers to be a bit a higher level, so that it compensates some building problems or some actual real life differences. So we have this glazing index 0.85, but actually we are putting windows that are ranked 0.8. So we hope that the final product could be more like these numbers, not less, as it usually comes to real life. So it's about it. Yes, the building is actually right now getting a building permission, so we hope to have it built the next year. So it could be the already built example of this thermodeck system, so we can have it as an example to see how it actually works, because now the system is used in Sweden and northern countries more, but not in Baltic states, so it's pretty hard to persuade a client for something new when he can't see actually already built examples. So if you have any questions.
We do.
Yeah.
Paldies. Okay, thank you for the presentation. Maybe round of applause. Is this built or is still undergoing?
It's getting building permission, so we hope the building will start early next year.
Okay, so it's just in the planning process, yeah?
Yes, actually the project is already ready. It's going through permission through authorities, so
yeah.
We hope to get permission early next year, so
okay.
It should be built by next year.
It should be started next year, and how long will it take to build it? Because you said that it's going to be quite fast solutions, yeah, for construction.
Yes, so it should be built during next year.
During next year? Wow.
Yes.
Okay.
If everything goes as planned, so.
Sounds fast. Okay. We have a couple of questions. One is, okay, I'll try to conclude it. Does the efficiency now gets more important compared to the architecture of the building? Meaning, does the developer actually put efficiency of the building in front of the architecture and maybe doing some compromises in the architecture to get higher efficiency and, you know, better quality? Like.
Of course, it depends on the client, on the developer. It's very common that they actually put the costs in front of architecture, but they are now also putting efficiency first because they see that it pays back in a long term.
Okay, so efficiency
is important
first, and
yes.
then architecture and beauty.
No, of course it depends on the client, but
okay. Practical question, and I see five likes for that. What about the dirt of concrete in the thermodeck when constructing?
Yes, that is a good question, but these slabs are built on factory. They are washed and sealed, and when they come to construction site, they are still sealed and they are opened just before the ducts are connected. So actually, they are clean.
So okay, I will not be able to elaborate on that. So if anybody wants, just catch Kaspars.
Yeah.
Okay, thank you very much for your presentation.